Hello everyone. We are going to study about one of the most important topics of chemistry. Yes, and that is mole concept. Before starting, I have a question for you. If I give you 1 dozen bananas, then how many bananas do you get? Of course, 12. Similarly, chemists also use a fixed quantity, that is mole. Okay, so just like 1 dozen is equals to 12 objects, 1 mole is equals to some fixed number of particles. Let me write 1 dozen is equals to 12 objects. In the same manner, 1 mole is equals to this number of particles. Now, if I talk about the objects, you can put any objects here. Means you can put bananas, oranges, or balls, etc. Similarly, if we talk about the particles, they can be your atoms, ions, and molecules. So, 1 mole is equals to 6.022 into 10 raised to the power 23 of particles. And this number is called Avogadro's number. Avogadro's number. Now the question is, why do we need this mole concept? Actually, atoms and molecules and ions are extremely small. We cannot deal with a single atom or molecules. So that's why chemists decided to deal with a bulk of particles. That's why they have given this quantity, this fixed quantity, 1 mole is equals to Avogadro's number of particles. Now, if you talk about the number of atoms, means if you talk about 1 mole of sodium atoms, then it will contain 6.022 into 10 raised to the power 23 atoms. If you talk about molecules, then 1 mole of, let's take an example of water. Let 1 mole of water molecules is equals to Avogadro's number of molecules. Means if you talk about atoms, then you have to write atoms. If you talk about molecules, then write molecules. Okay. Now the question is, can we count these number of particles? Of course not. So this quantity is made related with the mass of the particles. The relation between moles, number of particles and mass is given by this equation. 1 mole is equals to Avogadro's number of particles and molar mass of the substance you're talking about. Let's take an example, water. And of course, this is a molecule. So if we take 1 mole of water, then it will contain this number of molecules and this number is equals to molar mass of water. Now, molar mass of water. Okay, now calculate the molar mass of water. The number of hydrogen is 2. Multiply with the atomic mass of hydrogen atom, and that is 1. Plus number of oxygen atoms, that is 1, and multiply with the atomic mass of oxygen atom, which is 16. Now if you calculate the molar mass of water, then it will come 18 gram. Means 1 mole means 1 mole is equals to molecules is equals to 18 gram of water. If you take another example of molecule like CO2, then again, first you have to calculate the mass of one molecule. Means 1 mole is equals to Avogadro's number of particles and is equals to molar mass of the substance. Okay, now we are going to learn about the formula, how to calculate number of moles if you are given mass of the substance. The formula is number of moles is equals to given mass upon molar mass. Okay, you can calculate number of moles by this formula, given mass upon molar mass. Okay, now we will solve a numerical based on this formula. Question is calculate number of moles in 88 gram of CO2, means carbon dioxide. First of all, you have to calculate the molar mass of carbon dioxide. Again, the number of carbon atom is 1 and multiply with the atomic mass of carbon, which is 12 plus, and there are 2 oxygen atoms, so 2 multiply atomic mass of oxygen, and that is 16. If you will add these two quantities, you will get 44 gram. Means the molar mass of carbon dioxide is 44 gram. Now the number of moles is equals to given mass, which is 88 gram, upon molar mass, which is 44 gram. If you will solve this, you will get 2. Means number of moles of carbon dioxide in 88 gram is 2. So you can see that the 1 mole is a fixed quantity which is equals to Avogadro's number of particle, and it is also equals to molar mass of the substance. We have also learned about the formula how to calculate number of moles if we are given mass of the given substance. Okay, so thank you for watching.